what I'd like to do is I'd like to talk about some things in your textbook before we get started on the section 1.1 lecture. So the first thing I want to do is you do have access to the ebook through my stat lab, and your book is a wonderful thing. If you would like access to a print version of the book, you can get that uh, under purchase options on your my stat lab page. So let me go back. So I opened up my stat lab. This is the first assignment. There are the purchase options. You click on that and you will get to a link for a print version. You can get the print version here for about $90. It's 3-hole punched. There's going to be some things you don't need, but that might be economical for you. This version was new in January 2017, so there aren't going to be a lot of used copies around. But it is an important thing. If you have access to the 12th edition or the 5th edition using Excel, that will be also advantageous to you, but some of the page numbers I refer to won't be the same, but you've got your ebook, so you'll be able to see that. So that's an option if you like to have a hard copy book. I like to have the book in front of me, but I am not going to require that you buy a hard copy of the book if the ebook works for you. But I'm going to say you need to read the book, and you should read the book before you listen to the lectures. One of the things that this author is very good at is they've got these sidebars that are very, very interesting. I recommend you read all of them. I may or may not mention them in the lecture, but this one about bombers that came back during World War II is very interesting. There are some that are meant to be a little bit humorous, uh, but they give you good information. So by reading the textbook and looking at the visuals, including those sidebars, will give you a much rounder understanding of statistics. So I highly recommend that. I do want to add that the answers to the odd exercises out of the textbook are found in Appendix D, and you have access to that with the ebook. So let's go ahead and get started. So statistics is a science. I know it's labeled as a math class, but it's a science. So we are going to go beyond calculations to what do those calculations mean. So we're going to extract information from numerical data, and we will get that from an experiment or a sample, and we'll talk about the difference between experiments and studies in the future. Now in your book, on the introduction pages of the chapter, you've got some things that talk about flaws, and the first flaw they talk about are misleading graphs. And there's a lot of information on misleading graphs, but you can read through that and see what you find about that. And then there are bad sampling techniques. There's no amount of fancy math that's going to fix bad sampling techniques. And I will tell you that there are studies out there with bad sampling techniques. Once a study is published, it's hard to get rid of it. For instance, a few years ago there was a study that was published that said cell phones caused cancer in the head and neck. Well, that study has been refuted, but about every 3 years somebody finds that study somewhere on the internet and they quote it again. And the whole thing comes up again. So because of the internet, it's very difficult to get bad studies out of the public domain. So let's go on and let's talk about what statistics is. So the first thing we're going to do is we're going to design the experiment or sampling procedure. And if you go into a higher level of statistics and you're going to do your own study, this part's a big deal. In fact, when a person gets their PhD, they are gathering data, and it's a 5-chapter book, and the first 2 chapters are over the design of your study or experiment. And then there's analysis of the math, that is another chapter, and then making statements about the population based on the information that you gathered, that is your last chapter. And so these are 3 big deals in statistics. We're going to talk about the design in the first unit. We're going to talk about analysis in the second unit, and we're going to make inferences in the third and fourth units. So the first thing we have is we have data, and that is a collection of our observations. And just FYI, data is a plural word. Datum, D-A-T-U-M, is the singular. The population is all measurements being considered. And we can collect data from the population in 2 ways. We can do a census, and that's data from every member of the population, and we can do it using a sample, which is a subset of the population. Now, you may have heard of the word census before. In the United States, we have a census every 10 years to count people, to get data from the people, and federal dollars are distributed according to the census. The Constitution of the United States says there shall be a census. That means it will happen, and that means you get data from everybody. But the census also, besides counting people, asks how many miles do you commute, how many bathtubs do you have in your home, how many phones, etc. Well, the government has gone to collecting that kind of data by sample. So let's say every 30th person on the list gets an extra long questionnaire to fill out about additional things. But the Constitution says that every individual shall be counted every 10 years using a census. And again, here's my grammar alert. Data is a plural word. So when you write your conclusions, you should write the data show, not the data shows. Data is a plural word. It needs a plural verb. Plural verbs don't usually have S's. This is a graphic out of your textbook to help us think about what we're doing. So we need to prepare our study. We need to look at the context of the data and what was the goal of the study. We need to look at the sources of the data and are they reasonable, and we need to look at their sampling method. There are good sampling methods and there are bad sampling methods. In this time in our study, we're going to talk about bad sampling methods, which is a voluntary response, and we'll talk about that a little bit, I think, in the next slide or two. Then we're going to analyze the data, and we graph it so that we can see it visually. We check to see if there are outliers. We're going to summarize the data with statistics, and that's what we're going to do in chapter 3. We're going to look at what the distribution looks like. Are there any missing data, and did many refuse to respond? We're going to look at shape, center, and spread when we explore the data. And then we're going to use statistical methods to obtain results. a conclusion. And then in our conclusion, we decide if the results have statistical significance, yes or no, and practical significance, yes or no. And these two things sometimes are very, very different. So let's look at the context of the data first. What do the data mean? What was the goal of the study? And the source of the data. Now, thinking about the source of the data, was it objective? Most of the time, research journals are objective, where business and industry journals may not. And is there a value gained by distorting the results? Okay, here's an example. When I was teaching middle school, we got this most wonderful unit on recycling and the waste stream that goes into the landfills, and it was published by the Plastics Council, and all of the activities showed that by weight plastics were much less a problem in landfills than paper was. Okay, let's think about it. If you have a garbage can full of styrofoam peanuts, or you have a garbage can full of folded newspapers, which one's going to weigh more? Well, of course, the newspapers are going to weigh more, but there's a whole lot more there. Weight versus volume. Weight isn't what fills up the landfills, it's volume. So all of those activities were tilted toward a positive attitude to in that case. Now, most companies don't use purely styrofoam peanuts. They are they don't break down. But now they use a corn-based foam for those packing peanuts, and they break down when they get wet. Okay, so there has been a change in the last 30 years about what we use for packing materials. What was the value gained by distorting the results? Well, middle schoolers would have a much more positive attitude toward the plastics industry. So we always need to examine the objectivity of the source. We need to be a smart consumer of statistics. And to be truly honest with you, that's my goal for you in this course, is for you to become a savvy consumer of statistics, that you talk the talk and walk the walk. If you do some research into the relationship between smoking and cancer, there was a long time where the tobacco industry had all kinds of studies that showed that mouth cancers and lung cancers were not related to smoking. That became obsolete it might have been in the 90s, when the tobacco industry finally did say, yes, smoking causes cancer. So sampling methods, they're good and bad methods. As I said before, just because you put lipstick on a pig doesn't mean you have a beauty. So again, no amount of mathematical manipulation can fix poorly collected data. And one of the worst ways to collect data is a voluntary response sample. And a voluntary response sample is something like on Dancing with the Stars, that you call in and you vote for this couple, or you vote to eliminate that couple, because what happens is you choose to be part of the sample. The best possible samples are simple random samples, and we'll talk about that more when it becomes more appropriate. Bias. Bias is a word that means the outcomes favor one opinion or another. So we're going to analyze the data, we're going to graph and explore, we're going to use the statistical methods, we're going to make conclusions, and we are going to Clearly state the meaning, keeping jargon to a minimum. Now, there is a place and a time for jargon, and we will use statistics specific jargon, but there's also times to put it in plain language so anybody can understand it. And then when in statistics we talk about significance, there's practical significance and there's statistical significance. One of the things that they talk about, it may have been in another version of the text. They talk about the Atkins diet, and they gathered data and they found that on average, participants lost 2.1 pounds per year, and that was statistically significant. And we'll talk about what it takes to be statistically significant in the next unit. But is it practical to go to all that work to lose 2 pounds? Or I might have something that could improve second graders' spelling scores, and it is very statistically significant, but it costs $3 million per school to implement. Then it's not practically significant. When it has statistical significance, it's unlikely to happen by chance. And practical significance, does it make sense to implement the changes? So if I said I'm going to toss a fair coin and I get heads 52 times out of 100, that's more than 50%, but it's not statistically significant because it could happen by chance. If I got 98 heads out of 100, then I'd question whether my coin was truly fair, and there is a difference between heads and tails. When we make our conclusions, we want to avoid misleading conclusions. Correlation does not imply causation. Be cautious of reported data. And the example I use for that one is the weight on your driver's license. When you have someone who would like to be less round than they are, they may report a lower number on their driver's license simply because it makes them feel good. Or let's say you're doing a study and you ask someone, how many servings of fruit and vegetables did you eat last week? Then you're relying on their memory to give you that information, and our memories are not that good. Also, if you have very small samples, you can get very wrong conclusions, and we'll talk about the size of samples that are required in, I think, in Unit 3. And then there are loaded questions. We'll look at an example of that, and we'll look at the order of questions on the next slide or two. Here is a loaded question. Okay, here is the one that has as little bias as possible. If you found a wallet with $20 in it, would you return the money? Where if I ask the question like, if you found a wallet with $20 in it, would you do the right thing and return the money? So then what's happened is we've put a value judgment into the question. And well, yeah, I'll do the right thing. You don't want to say out loud you wouldn't do the wrong, that you would do the wrong thing. So when you're asking survey questions, it is very important what they look like. And there are whole courses on writing surveys. And we won't go there, but if you're asking things and you're tilting the questions negatively, you have to have a similar number of questions that tilt things positively. So if you've ever taken a survey for research and you feel like, well, I just answered this question before, but agree or disagree, I hate math. Agree or disagree, I love math. And so you might get questions that look the same, but it was their tilt, and that's why they needed to ask them both with a negative slant and a positive slant. The order of questions. There was a study that was done and it asked college students, how often do you normally go out on a date? About blank times a month. And then the next question was, how happy are you with life in general? Well, there turned out to be a very strong association between these two questions. The more times the person dated, the happier they were. But they reordered the questions and there was no strong association between these. So the order of the questions makes a big difference. We want to avoid misleading conclusions, and we want to talk about non-response and response bias with that. There was an author who wrote a book and she sent questionnaires in the mail to 100,000 women and asked about their relationships. 4.5% responded. But that means over 95% didn't respond. She used those, let's see, 4.5% of that would be 4,500 responses. She used those to write her book. And her book was very anti-male, because who is more apt to fill out the survey and send it back in? Well, angry people are more likely to respond. If there was a door-to-door survey being conducted to determine drug use, you're going to get different answers than if you did it by phone, because I'm saying it out loud, you know who I am. I may give socially acceptable answers rather than truthful answers. What if someone in a uniform was conducting the interview? Then the interviewer introduces bias into those responses. We all like to look smart. So there was a poll done in Cincinnati and it was published. And yes, this is old, but it's a good example. People were asked whether they favored or opposed repealing the 1975 Public Affairs Act. Well, there was no such act, but about 1/3 of the people who were asked expressed an opinion about it, even though it was imaginary. They had no knowledge of it. So we need to be careful about the weight we give on people's opinions. Some people have very, very informed opinions, but other people have very uninformed opinions. So you need to be careful, and I guess Facebook just popped into my head as we talked about this. And just remember, statistical thinking is much more than performing complicated calculations. And I just want to say one little bit about this is there's going to be a few things that we're going to calculate by hand, but most of the time we're going to use StatCrunch to do the calculations. I want you to think about the formulas for the numbers that we're going to be using, but we're going to use the tools we have to do our work, and then our work is going to be using those numbers to make decisions.